All right, the second method we have for solving a quadratic equation is to use the quadratic formula. And I mentioned the quadratic formula in the last video and how it's kind of complex. It has a lot of stuff going on, square roots, squares, positive, negative, plus, minus, all that stuff. And there are a number of opportunities for you to make simple mistakes that will change your result. So this is an option for you to use, and what I would suggest is that you only use it if you absolutely have to. Um, if you can factor something to be able to find the solutions, that would be much easier than using the quadratic formula. But sometimes we have no choice, and you'll see why here in a second. All right, so let's go ahead and just apply this quadratic formula. So the quadratic formula is based off of the coefficients in the quadratic equation, the a, b, and c. So you can see here it's x, or x being our x value of our solution, right, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that plus or minus is how we are going to get two answers. All right, so that plus or minus means I do it one time with plus in there, and then I do it a second time with minus in there. Now you don't have to do all the work over again. We'll do the plus or minus at the very end, okay? All right, so the key to doing this is identifying your A, B, and C. So if we just look at that first problem, I can identify my A, B, and C here as A is equal to 2. And this one's a good example because there is no number right next to the x, but we know there's a number there. And we have a minus sign that indicates that that's a -1. And then c is a -6. All right, so if we're going to apply the quadratic formula says x is equal to -b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. All right, so if you can memorize that, that would be great, because it's something that we're going to use occasionally, and if you have it on the top of your head, that's going to be really helpful. All right, so let me see here. I got to make sure I have, enough space. Oh, I got plenty of room, I hope. So now I'm just going to plug in my A, B, and C. All right, so it says the opposite of B. Well, if B is already a -1, the opposite of that is +1. So it's going to be 1 plus or minus square root. So you can already see with that first term, we could make a mistake and we'd mess this whole thing up. Okay, and then we have B squared. Well, B squared is -1 squared. So -1 squared is -1 times -1, or 1, right? So I'm just going to plug in a 1 there. And then we have minus 4 times 2 times -6. And then we divide the whole thing by 2 times 2 because our A is 2. All right, so I simplified some of the things right away. So I simplified this one right away and this one right away, but I left the other ones just so we could see how those plug in. All right, so now I'm going to simplify those two. Okay, so I have x equals 1 plus or minus the square root of 1 minus, is it going to be minus? And this is kind of the tricky part. And this is where some of you are going to make some mistakes, because if we notice, we have a -4 basically, a +2, and a -6, and we're multiplying them all together. And since two of them are negative, the -4 and the -6, we know this is going to end up being a positive number. So I'm just going to change that to a plus sign. So 4 times 2 is 8, times 6 is 48. So I'm going to go ahead and put a 48 in there. And then I'm going to divide this whole thing by 4. All right, so we're just going to keep rolling. We can simplify a little bit more. So that can become 1 plus or minus the square root of 49. That's a good thing, because I know the square root of 49. And that's going to be divided by 4. And then we end up with x equals 1 plus or minus 7 over 4. And now this is where we get to get our two answers. So right now we only have one thing there, but the plus or minus represents two different versions of this thing. And what we're going to do is just split it now into two different equations. So we have x equals 1 plus 7 over 4, and x equals 1 minus 7 over 4. All right, now 1 plus 7 is 8. 8 divided by 4 is 2. 1 minus 7 is negative 6. Negative 6 divided by 4 is not a number that we could have found by factoring. So it's negative 1.5, right? All right, so this one is simplifies to a nice neat decimal. If they do, that's perfectly fine to simplify to a decimal. If they don't, you got to leave it as a fraction. All right, so we have our 2 and our negative 1.5. So we know that our two solutions, or the 2 points where this graph crosses the x-axis, are 2, 0 and negative 1.5, 0. All right, so there we go. Now, this one, we could not have found the answer by factoring. Well, wait a minute, maybe we could have. Let me see here. Actually, we could have. Yes, we could have. And here's how we could do it. So let's just do this really quickly so you can see. Now, this is one we didn't do by factoring in the previous lesson. We just had everything with a equal to 1, right? But this case, a is equal to 2. So we could factor this thing into binomials that are 2x and x and equals 0. So this is good because this, I think, is going to show us what we want. All right, so then we have to figure out, all right, I think this one's going to be minus 2, and this one's going to be plus 3. Whoops, I can't write here. Yeah, this is good because this is going to show us something important here. All right, so if we can factor that into those two binomials. Now, this is a little bit more difficult factoring, but if you'd rather do this factoring than the quadratic formula, you're welcome to do it when you have the choice. If I tell you to use the quadratic formula, I want you to use the quadratic formula. But if you see you can factor this thing into these two binomials, and then you can figure out how to make those into zeros, then you can be more than willing to do that. Or I'm more than willing to let you do that. So here we have the first one. If I want to make that 0, 2x plus 3 equals 0. So I subtract 3. So I have 2x equals negative 3, and then I divide by 2. X equals negative 3 over 2, or negative 1.5. Look at that. That is the same as that. So that's where that one came from. And then if we look at that second binomial, it's pretty obvious that it's going to be 2, right? Because x minus 2, remember the opposite of the 2 is what our x is going to be, so it's 2. Okay, so that we can see that the opposite of that negative 2 is how we got that 2. Okay, so I'm doing this because I'd rather see you avoid the quadratic formula if you can. And if you see that you can factor something, I would much rather see you factor it than use the quadratic formula. Because if you look over at the factoring, fairly simple steps, right? If you look at the quadratic formula, lots of complex steps, okay? All right, so let's do another one here. And this one is a good example because I talked about it the other day in the other lesson that the, sorry, there was something on my screen I had to get rid of. The quadratic equations have to be equal to 0. And in this case, it's equal to 9. And so all we have to do is turn this thing into a quadratic equation by subtracting 9. And when I subtract 9 from the left-hand side, I'm not going to change any of the terms that are there because none of them are like terms, so I just add it onto the end. So I have minus 9 and then equals 0. Okay, so there we go. We have a quadratic equation now because it's equal to 0. And so what I can do is I can add, or I can figure out my a, b, and c. So I have a is 4, b is 2, c is negative 9. And so I can apply the quadratic formula. So I have Let's try and do it without writing the formula down first. X equals negative b, so negative 2 plus or minus the square root of b squared. Well, b squared is 4. Minus 4 times a, which is 4, times c, which is negative 9. All right. And then all divided by 2a, or 2 times 4. I'm just going to go ahead and simplify that one. It's 8. Okay, so simplify some here. So we have negative 2 plus or minus the square root of 4. Again, this is just like the first one. There's 2 negative signs there, so it's going to become a plus. So we have 16 times 9. So that is 90 plus 54. So that's 144. Okay, and then we are going to divide that all by 8. Now, some of you might be tempted to say, hey, these are all even. Can I divide them all by 2? No. And the reason is because of that square root sign. We can't mess with those numbers under the square root yet. All right. Let's see here. We're going to simplify a little bit. So we have negative 2 plus or minus the square root of 148. Uh-oh. We're going to divide that by 8. And so we have x equals negative 2. Well, wait a minute. Plus the square root of 148 over 8. And negative 2 minus the square root of 148 over 8. Now, the problem is the 148 doesn't have a nice, neat square root. And we can't really simplify that down to a number that we could add or subtract from negative 2, right? So technically, these are our 2 answers right here. And we would write them just like we would any other points, right? I'm trying to figure if I want to do something or not here. So that would be, yeah. Let's just leave it at that for now. What I'm considering here is whether or not I should have you simplify those radicals. And since we haven't talked about it yet, let's do this. I'm going to show you how to simplify them, but if you can do it, that would be great. All right, so the way we're going to simplify this radical is we have square root of 148. So when I said radical, I meant the square root, if you were confused by that. So the square root of 148 can be written as the square root of 4 times 37? 37, I believe. Yes. Okay, and you're maybe wondering, well, why'd you do 4 times 37? Well, because I can split this into the square root of 4 times the square root of 37, and it becomes 2 times the square root of 37 because I can simplify the square root of 4. All right, so technically, my answer is going to use that 2 times the square root of 37. So this is going to become negative 2 plus 2 times, oops, hold on, the square root of 37 over 8. And this one is going to be negative 2 minus 2 times the square root of 37 over 8. And then this is where the math gets kind of tricky. We can simplify that a little bit further because this is a 2, this is a 2, this is an 8. So I can eliminate a 2 from all of these, right? So we end up with negative 1 plus the square root of 37 over 4. Okay, so I factored a 2 out of everything. And I don't have to bring it along because in this case it actually disappears. And then negative 1 plus the square root of 37, or sorry, minus, whoops, over 4. All right, so this is a little bit more complex how we have to take our final answer and write it. And I'd love to see you be able to try and do this. And if you're struggling with the simplifying of that radical, that 148, that's something that you can ask me for help on, and I will help you figure out how to do that, okay? But technically, you know, we're not quite done because we have to write our answer as a point, right? So we have -1 plus the square root of 37 over 4 and 0. And then we have -1 minus the square root of 37 over 4 and 0. Okay, so this is technically our answer right there. So a little bit more complex. And so, like I said before, you can see how if you can factor, you really want to be able to factor. But sometimes you're not going to be able to factor. And just based on this answer alone that we just got, this means that we can't factor this thing. So we have to use the quadratic formula with something like this. Okay, so the next thing is just another example that shows you how a comparison between the two. So if we look at this problem here, x squared minus 12x plus 11 equals 0. We're going to do it by factoring and by the quadratic formula, and you can just watch. I'm going to use way less ink on the left-hand side than I am on the right-hand side. So if I look at this, I can say, wait a minute, 11 and -12. I know that 11 times 1 is 11, and 11 plus 1 is 12. So I can write this as x minus 1, x minus 11 equals 0, and it's minus because it's a -12. And so that means my x's are 1 and 11. So I have 1, 0 and 11, 0 for my two answers. Super fast and simple if you choose the factoring method. Now we can do the exact same thing using the quadratic formula, but you'll see it's going to be a lot more complex. So here we have a is 1, b is -12, c is 11, and we can use the quadratic formula. So we have x equals -b, so that's going to be the opposite of -12, plus or minus the square root of, -12 squared is 144, minus 4 times 1 times 11, all over 2 times 1, or just 2. Okay, so already complex, right? So we're going to keep simplifying. Okay, 144 minus 4 times 1 times 11. Well, there's only one negative there, so we actually are going to be subtracting from 144. So we're going to be subtracting 44 from 144. Okay, so when we do that, we end up with 12 plus or minus 100 over 2. Well, the square root of 100 is nice and neat. That's 10. So we have x equals 12 plus or minus 10 over 2. And then we have 12 plus 10 over 2 and 12 minus 10 over 2. So this is 22 over 2, or 11. Oh, look at that. And this is 2 over 2, or 1. Same answers, right? So a lot more work, but the same solution. So you can choose which way you want to go, right? And for those of you who are taking or who have taken the ACT exam this week, this is a perfect example of a type of problem that's going to mess you up on the ACT, because if you do the quadratic formula method on the right-hand side, it's going to take a lot of time, and time is something that you don't have a lot of when you're doing the ACT exam. So if you can do it by factoring on the left, factoring on the left took us what, like 30 seconds, right? But the quadratic formula might take you a couple minutes, and that's a huge difference when it comes to taking something like the ACT exam. All right, so you have a bunch here to do. So the first page of the assignment, you're going to do the exact same two problems twice. The first, do it by factoring. The second, use the quadratic formula. And that'll help you get used to doing the quadratic formula and identify any mistakes, because hopefully by the factoring method, you'll be able to get the answer pretty quickly. And if you have something different by the quadratic formula, you can then look for and identify what sort of mistakes you made. And then on the last page, there are 6 of them where you get to choose whatever route you want to go. And it says there to try to avoid the quadratic formula if you can. And I would highly recommend that. If you want to try factoring the ones, even if they have a greater than 1, I would suggest trying it, because it's a lot easier than going through that quadratic formula. All right, if you have any questions, let me know.